Hey, and welcome back to Science. Today we are going to take a look at phase changes and how to address them, how to model them using energy bar graphs. First, let's take a quick look at what those different phase changes are. You already know these, so we're going to go through them pretty quickly. One phase change is when you go from a solid to a liquid. What do we call that? Pause it for a moment, write that one down. That's right. That's called melting. What happened to the Wicked Witch when water was thrown on her? In order for a solid to turn into a liquid, it's going to have to gain energy. That's really important. So it's going to have to gain energy, absorb energy from its surroundings or from something that is touching it. That's why holding an ice cube in your hand feels so cold, because in order for it to melt, it's taking energy from your hand. Some classic examples of this. Ice melting, as we just said, a candle. You light a candle, that wax is solid, some of that wax melts into a liquid. Fondue pot, if you've ever used one of those, that is another good example of melting. Okay, let's get that one done nice and quickly. When you go from a liquid to a solid, we call that one freezing. The important part here, the thing that I really want you to emphasize, is that that liquid is going to need to lose or give away energy in order for it to freeze. In order to go from a higher energy liquid down to a lower energy solid, it needs to lose energy. Some examples. Once again, liquid water can freeze into ice, and that candle wax, that liquid candle wax, after the candle is put out, it will freeze. More on that one in a bit. We're going to use that as one of our examples today. Okay, next ones. See, this is a little bit trickier one. Do you know what is called when you go from a liquid into a gas? Pause this right now and write that down. See if you know it. I'm going to go on a limb and say that you're going to have a close word, but you won't have the right word. If you said vaporization, no E in front of it, nicely done. That's a tricky one. So the most important part, again, to go from a liquid up to a high energy gas, the liquid needs to gain energy. Real quick version is, in order to have enough energy to separate itself from all of its neighbors, to get away, or to be able to do that, it has to gain a lot of energy to break those bonds that are holding it near its neighbors. So it takes a lot of energy to do that. Evaporation is a specific kind of vaporization. It's specifically when it happens at the surface of the liquid. When it happens at the bottom, we call that boiling. Both of those are examples of vaporization, of a liquid turning into a gas. Examples, well, there's plenty of them. Sweat. That'll be another one that we have as an example, but sweating cools you down by its evaporating. Hand dryer. The reason that it's a warm hand dryer is air is going over your hand, adding energy. Warm air is going over the liquid, adding energy to that water, evaporating it. The opposite direction, when you go from a gas to a liquid, that happens to be called condensation. It's not the exact same thing as rain. In order for rain to happen, some of that water in the air has to condense. But a lot of people say condensation and they mean rain. Condensation itself is a process the way we are using this right now. That gas has to lose energy. Gas is the highest energy of our big three, so it has to lose energy to drop down into the liquid phase. Classic examples. Cold drinks in warm weather Sometimes they look like they are sweating. That's actually going to be part of an assignment you have for next week. That is water vapor, humidity in the air. Water in the gas form that is turning into a liquid. It is condensing on the side of your mug. If you've ever been to the desert, to Arizona, you don't see that happening. You don't see any or very much condensation because it's so dry. It's not humid out. You probably don't notice it very much in the winters around here in your house. But in the summers, July and August, when it's yuck humidity, you'll notice that happening a lot. Clouds and rain, again, as it is going from the gas phase into the liquid, that is a process of condensation. When you act like smog and you can see your breath. Okay, there's a few of you that act like you're smog. I know who you are. I'm one of them too. When you can see that breath, well, your breath is very moist. That's why when you blow on a mirror, you can see some condensation right there. When you exhale in the wintertime, it's tiny, tiny, tiny droplets of liquid water that you are seeing right there. Okay, a couple of them just for your interest. Going from a solid to a gas is called sublimation. It needs a lot of energy to do that. Best example is dry ice. This is why dry ice feels incredibly cold if you were foolish enough to touch it. I'm going to leave these others up here. You can stop it and pause it if you want. Going in the other direction is called deposition. Couple quick examples for that one: snowflakes, or if the inside windows of your car ever look like a giant snowflake, that's what's going on right there. It's skipping over the liquid phase, going straight into a solid. Moving on to what's important here. When we represent phases on energy bar graphs, we have to assign certain level for each phase. This is rough, but we're going to do this. We're just going to say, hey, a solid is 1 bar of phase energy. A liquid has 2 bars of phase energy. And finally, a gas has 3 bars of phase energy. This is far from perfect, but it is a useful model to use to start thinking about what's happening during phase changes. It's far from perfect, but it's a good starting point. It's a way to get our brains starting to think. So let's take a look at a couple of examples. This is what you'll be doing on your assignment tomorrow. So take a look at these. Let's start with candle wax. Let's say you're holding a candle and some of that liquid wax accidentally spills onto your hand. Ouch! That hurts. I don't like that feeling. How would that look on a energy bar graph? Well, I had to pick some number for the thermal energy. What number I picked really doesn't matter. I picked the liquid wax to have 3 bars of thermal energy representing the high temperature. The phase, that one I'm kind of locked in on by what we have set. Liquid has 2 bars, so I'm giving 2 bars of phase energy. So now when it lands on me and freezes, I've got to have something here. Here's what I chose. I said the temperature must have dropped a little bit as it's on my hand, but the phase, as it froze, it turned into a solid. So I don't have a choice on this one. This has to be 1 bar. This one, that's how far I think the temperature changed. Now the big question is, how can I go from having 5 bars of energy down to 3? What happened to those other 2? Well, they left to your hand. That's why it hurt. That's why it felt like your hand was burning, or why it burnt you, why it was hot. We defined many weeks ago something that feels hot is thermal energy transferring to you. I said before that these models are far from perfect. To be honest, my understanding of it is the majority of the thermal energy transferring to you is actually coming from that wax freezing. Yes, it is freezing hot on your hand. It's giving away energy in order to freeze. On a side note, in the late autumn, when lakes are starting to freeze, the temperature is a little bit warmer near them. Why? Because as it freezes, it gives off energy. There is yet another reason why we, surrounded by Lake Superior, are a little bit warmer temperature. Not only is that lake a giant heat sink, but as it freezes, it's dumping thermal energy into the air. Fun. Okay, the other example, our last example for today. You now have a sweating problem. Okay, fine. If you're kind of grossed out by that, you have a layer of water. Maybe you just climbed out of a lake or out of a shower. You've got a layer of water on you, and it evaporates. Let's take a look at what happens. Because it's liquid water, I had to go with 2 bars of phase energy. I got to pick however many bars I wanted for thermal. I'm choosing 2. As it evaporates, going into a gas, I have to represent 3 bars there. Now I'm choosing to say that the temperature isn't changing much. The liquid if it's sweat in particular, is the same temperature as my body, but it is turning into a gas. So the next question is, where did it get this extra energy? It has 1 extra bar. Well, it's coming from you. That's how sweat cools you down. If you've ever climbed out of if you've ever been in a lake or a pool and you notice that when you get out it actually feels colder than when you're in it, that very well may be due to that evaporative cooling happening. So, here are 2 examples. Again, the homework that we have for tomorrow will be doing some of this. You'll have 3 of these problems. 2 of them have a follow-up to go with it. You'll be fine. Watch this video again. You'll be fine. Do your best. Start thinking about these changes. Pay attention to them. They're all around us. Science is all around us. Till next time, have a great day.